I'm here today to talk about RethinkDB cluster monitoring. I'm going to show you how to build real-time web app with RethinkDB that shows real-time data graphed. My name is Ryan Paul. I'm a developer evangelist at RethinkDB. I mostly do content, blogging, and presentations. So I've been at Rethink since September, and I do a lot of application development and demos and stuff. So the demo app I'm going to show you how to build today is like a cluster status monitor. It shows you how your RethinkDB cluster is performing. It shows you a real-time graph of reads and writes, plus it will show you the health of every node in the cluster. So a screenshot doesn't really tell the whole story here, so I'm going to want to switch over here so you can see real quick what this looks like. Here's the graph, and it's actually showing writes in real time. I wanted to have some activity on my cluster just so you could see it drawing something. So I've got a few apps running in the background. Every time somebody posts a cat to Instagram, it writes a record to my database. So I've also got it tracking every Bitcoin transaction. So I've got some data going on in the background here, which should be sufficient to get a nice line for our database writes, as you can see. So yeah, this is the app I'm going to show you. The back end is written in Go. The front end is written with Polymer and a graphing library called Epic, which I'll talk about in a little bit. Before I get into the specifics of how I built this demo, I'd like to talk a little bit about RethinkDB 1.16, our latest release. We introduced some new features that are rather compelling. We added support for cluster administration through REQL query language. And we added a feature called system tables. We basically exposed internal data about the cluster and its health and configuration through actual database tables. So when you want to reconfigure the way that your sharding works, or if you want to pull out live statistics about what's going on at this moment in your database, you can access these tables and you can query them, and they'll give you live data. Now, the big feature, and this is something we care a lot about going forward, is change feeds. It's like a built-in publish-subscribe mechanism in the database. You can subscribe to a query and receive all updates on that query in real time, and you can have it pushed out to your application. So this changes the way that you can architect your real-time applications. Say you're building a chat application or an analytics application or a real-time game. You want to be able to get updates and show them to your user without having to poll, without having to reach out and ask the database every few seconds for what's changed. And what change feeds lets you do, it lets you see everything that's happening as it occurs. So I'll show you how some of these features can be used together here, and that's how I built this demo. Because as you can imagine, all these features compose really well. We have these system tables that give you statistics, and then you can attach a change feed to them, and you can actually get a live feed of statistics for your database. And that's basically how this works. Let me start by showing you real quick what this looks like. This is our database admin console. Let me increase the size here so you can see what I'm doing. We have a special database we call RethinkDB. In any cluster, this is how you access the system tables, by querying the RethinkDB database. Then we're going to reach into a table called stats. Make that bigger. I don't know if anybody can see that. So when we query that stats table, you can see the data coming out. We have data about the cluster itself, the queries written and read per second, the data storage information, number of client connections. Okay, now we also have statistics for individual servers, and of course also tables. So all the the information about your cluster is accessible through this query. Now, if we want to get a real-time feed on it, all we do is we add this command called changes. You see changes at the end? Okay, so now we're getting a live stream of events. Anytime that something gets written to the table, we'll get a new record, a new document that shows you the statistics, the latest current statistics. So that's what the application uses. So I built the back end for this, this cluster monitoring app in Go. And Go is it's a really nice high-level systems language that it's very simple, clean, easy to use, and as I'll show you, it has good support for a synchronous program that aligns well with RethinkDB change feeds and what we're doing. It makes it very easy to use. So yeah, the backend is Go, and I'm going to show you now what that looks like. Here is using our Go driver, the query that you use to fetch the statistics. And this is the query that I just showed you, but in Go you capitalize the method names. The Go driver is not officially supported. It's created by a third-party developer, a member of our community, and he actively maintains it. But the Go driver is one of the most popular third-party drivers for RethinkDB. We officially support Node.js, Python, and Ruby. We have first-class officially supported drivers that we maintain internally for those. But Go and Clojure and a number of other languages are supported by our community. This is the query to get cluster statistics, which you can use in Go just as easily as any of those other languages. And this is what it returns. You get the new val property is what every record that gets returned from a change feed has a new val property and an old val property. And that way, if you're looking at something that's changing, you can see the delta by comparing those two properties. In the cases of the statistics, like if you wanted to see what it was before, the previous state, you could query the old val. What I'm showing you here is just the new val. Obviously you can get statistics on any part of your cluster, the servers, the tables, the cluster itself. But we really only want the cluster stats, the ones where the ID is the string cluster. So we use a filter on the query in order to pull out just those records. Now this is where things get kind of interesting, because change feeds, when we were originally experimenting with this feature, it was just implemented against the table. You could see any changes to the table, but we thought, wouldn't it be great if you could get changes on any query, like an arbitrary recall query? And so we've been adding support for attaching change feeds to different kinds of queries, like a filter or ordered by. So like say you want to get like a specialized data set based on your query, you can attach a change feed to it, and then when the data that matches the query changes, then you get new records, then you get the updates. So in this case, I'm using the filter command to make it so that I only get records that relate to the cluster itself rather than servers and tables. And so we're attaching the change feed to that. Now we're getting just those records back from the change feed. And when you do this in an application, like obviously I showed you what this looks like when you do it in the console, you're just getting new records. But when you do this in an application, you need a way to consume the output. When you call this expression, what it gives you is like a cursor, like a window into the database, and then every time there's a new record, it comes up in the cursor. So you can iterate over that cursor and pull out the new records. Now, normally when you were to do that, it would be like a blocking operation. It would block the main thread of execution. So here's where Go helps us out. We can use a Go routine, our Go func expression, and we can iterate over the cursor in that Go routine. That just magically makes it happen in the background. That way it's not blocking the main thread. So what we're doing here is we're monitoring for those changes using that query. And then every time we receive one, we're broadcasting it through Socket.io. So Socket.io, for those who are unfamiliar, it's a framework for doing real-time web applications. You have a component, a server component on the back end, where you broadcast the information and handle information coming from the client. And then you have a client-side component that communicates with it. And Socket.io is cool because it's like it abstracts away the underlying network part of the communication. So like it'll use WebSockets by default, but in cases where, like, say the user's browser doesn't support it, it'll fall back to other transports, like long polling or what have you. So Socket.io is very convenient. And the main Socket.io library is written in Node, and it's intended to be used Node.js on the back end, and obviously JavaScript client on the front end. But there are third-party implementations of the Socket.io server for a bunch of different languages. And what we're using here is a Socket.io implementation for Go. So the top line here, we're just instantiating our Socket.io server. And then down here where we have server.broadcast2, we're just taking the data from the recall query and we're just broadcasting it over that connection. So any client that connects to our Socket.io server will be able to receive those messages in real time. And I mean, that's it. Like, this is all you need to take data from your database and stream it to the client. So next I'm going to talk about how I pick it up on the front end and display it. So the front end for the cluster monitor is built with the graphing library called Epic, which is built by the folks at Fastly. And Epic is it's a neat graphing library. It's built on top of D3. So I don't know how many people here have worked with D3 before. We got a few. Yeah, D3 is a fantastic library, but it's very complicated. It's designed to be very flexible and to give you this incredible expressive range of things that you can do with it. And the downside is that specific usage scenarios are often like non-trivial to implement. So in this case, doing like real-time graphing, it is a real pain with D3. So this library Epic, it makes it really easy to do like time series real-time graphing. They've kind of abstracted it away and made it so that those aspects of D3 are handled for you. And all you need to do is push new points and it'll add them. So that's what I use for charting. For other parts of the data, like specifically the data binding, if you look at the example here, you can see that I have information about the queries and writes per second displaying and updating in real time. And then I have a server list down here that's displaying in real time. I did that with Polymer, but I'm using Polymer only superficially in this particular demo because all I really needed was the data binding. I could have done it just as easily with Angular or whatever. But I like Polymer, and it was easy to use. I'll show you now. This is kind of cool. What you're seeing here is a list of the RethinkDB servers, the individual nodes in the cluster, which is on another table that we have, another system table. When I kill one of those nodes, which I'll show you now, see how it updates the app in real time? So that's just another query on another system table where we're pushing the data through Socket.io. So yeah, that's handled with just some basic iteration in a template, in a like handlebars style template with data binding. But I'm mainly going to show you the real-time graphing because I think that's the interesting part. Polymer data binding is pretty straightforward. So to plot data with this library, first you have to instantiate the chart. In the HTML, all I have is like this div tag with the ID that says it's a chart, which is what we're referencing here. So we start by grabbing that chart and then calling this .epic method to instantiate it. We're telling it that it has two axes on the left and bottom, and that the type is like a line graph that's time series. And then we specify, like we put in some initial values for each individual series of data, just so we can specify what the series are. So we have writes and we have reads. And then these are the initial values just set to 0 so that they both initialize at 0. I made a convenience function here called timestamp, which is just generating a Unix timestamp of the current time. As we add records, we'll just use the current time so that, for that axis. So now when we connect with Socket.io, we can set up Socket.io so that it receives a callback every time the server pushes a message with the name stats. Which is what our server is broadcasting to. The message here is just like to distinguish between different kinds of messages. So like for example, I have a separate message type called servers where I'm communicating the changes in server health and status, which I use for the servers. But for the statistics, for the graph, and then the stats under it, I'm using this like stats ID. And then it's just a regular JavaScript callback here. And all we're doing is we're taking the newest data that we've received from the server, and we're assigning it to a property, a JavaScript property that we can bind into. That's for the benefit of the Polymer bindings. Then under here, chart.push, we're just adding new records to the chart. We create like an array with one object for each series. We have our writes and our reads, and we're just taking the written docs per second and read docs per second, and we're adding them with the index of the current time. And so that just adds new nodes every time there's an update from the Socket.io server. And that's it. That's all you have to do in order to graph this data in real time. The library does the rest, and it'll handle the nice smooth animation so you can see the data stream across with a nice line. So it's pretty straightforward. That's really all there is to it for real-time graphing. And in this case, we're attaching the change feed to the stats systems table in order to get statistics from the cluster. But let's say you had some data in your application that you're putting in that you want to graph. You can attach that change feed to pretty much any kind of data that you want to pull out. Like say that you have a chat application, you want to show a graph of how many messages per second people are sending. You could just create a query that returns that, and you can pipe it through socket.io and display it in a table, or display it in a graph. So just for fun, I did one more thing here. Since I already had these change feeds set up and I was playing with these system tables, I thought it'd be cool to create an IRC bot that monitors for problems in the cluster and then sends you a notification in the channel that you specify. So let's say one of the nodes in my cluster drops. I get a notification from my IRC bot. It pings the channel. And I built this bot with Go. There's a really nice IRC library called GoIRC that makes it just breathtakingly simple to build an IRC bot in Go. The code you can see here is just initialization. What we do is we give the bot a name. This will be its nickname in IRC, my bot. Then we specify the server name. This would be like Freenode or wherever your IRC server is. I was testing it against a local running IRC server for test purposes, which is why it's localhost here. And then you instantiate the bot, irc.client. And once you've got it, you can send messages to it. You can send it commands. You can receive data from it. What you see down here is a simple handler. We wanted to make it so that the bot will automatically join a channel called My Channel when it connects. So when the bot connected event occurs, it runs this callback, which just forces it to join the channel. So this is just IRC code here. Now we're going to wire up RethinkDB change feed and plug it into the IRC bot. And here's where we attach the change feed. So you can see here a REQL query where we're using filtering. We're using a system table called current_issues. And that's a RethinkDB system table that exposes all of the problems with your cluster. So if there's like an error of some kind, or if a node drops or whatever, it'll show up in that table. We want to filter. We have a filter expression here so that we only get the issues that are marked critical, like high impact issues, which is like a server dropping. And then we attach a change feed to it. Now here's something that's kind of fun. We have this little bit of REQL after the changes command. You can actually modify or transform the data that gets returned by the change feed. In this case, we want to just pluck out the new val and ignore the old val. So that's why I have this field new val here. But you could do all kinds of things, like if you wanted to add extra properties, or if you wanted to perform a computation like summing some values that are in the record, and then you have it just automatically add that to the document before it returns it in the change feed. You can do that sort of thing. So here we're using a Go routine again so that the operation will perform in the background. And we're taking the issue document, the documents returned by this change feed, and we're deserializing them into this type, this struct, which has two properties, description and type. So Go is kind of cool. You can create these nested struct types and easily deserialize JSON into them. And the Go RethinkDB driver handles that. So when we iterate over our cursor, the cursor returned by the query, and we call the next method, and we basically apply the document to this variable with this type, it'll automatically deserialize the properties into the fields on the type. So the document has a property called description and a property called type, and we're going to get those in the data structure. You can do some interesting things here, like you can actually do nested structs, and it'll do deeply nested deserialization. You can also add a special decorator to the fields if you wanted it to bind against a different property. Like in this case, the field name and the property name are the same, but let's say you had a weird property name and you wanted to bind it to a field name that's shorter. You could add a little decorator or whatever. So I mean, there's some cool things you can do there, taking advantage of those features of Go. In this case, all we're really doing is we're generating a text message from those properties. We generate a text message where it has the like the issue type in parentheses, and then the full text of the issue truncated, split to the first line. And then we use bot.privateMessage and then channel. And what that does is it'll convey the text into the channel. So we've attached this change feed, we've deserialized the records, and then we've taken each of those records and we've turned it into a message that we just convey into the channel. So relatively straightforward. Question?